Hello everyone, I am Miss Phil and today we're going to look at recursive formulas for sequences. So we're going to go ahead and finish filling out the graphic organizer from last week. I'm going to go ahead and give you the recursive formulas for arithmetic and geometric sequences, and then afterwards we'll kind of talk about what they mean. So for an arithmetic sequence, the recursive formula is a sub n equals a sub n minus 1 plus d. So a sub n, we remember, is this nth term right here. And then we remember that the common difference is d. So this a sub n minus 1 is the new thing that we have to fill out. It's the only definition we didn't do last week. And that just stands for the previous term. So if I was looking for the 10th term, then the previous term would be the 9th term. Then for geometric, it's equally as simple. A sub n equals a sub n minus 1 times r, the common ratio. And that's it. The recursive formula just takes the previous term and either adds the common difference or multiplies the common ratio to get the next term. So let's look at this first example. Our sequence is 3, 6, 12, 24, 48, and so on. So I know that this is a geometric sequence. And I have the first 5 terms. So if I wanted to find the 6th term using the recursive formula, here's how I do it. We're going to write the recursive formula first. So a sub n equals a sub n minus 1 times, and then for the ratio, we know that that is 2. And that's how you write a recursive formula. That's all you need to do. But to find the 6th term, we're going to take 6 and plug it in for n. So when you do that, you would write a sub 6 equals a sub 6 minus 1 times 2. And that a sub 6 minus 1 is the same thing as a sub 5. So the 6th term is equal to the 5th term times 2. And my 5th term is 48. Right? If you come up here and you look, 3 is the first term, 6 is the second term, 12 is the third, 24 is the fourth, 48 is the fifth. So all the recursive formula tells me is that to find the 6th term, I need to take 48 and multiply it by 2. So the 6th term, a sub 6, equals 96. And that's it. That's how you use the recursive formula. Okay, so here's example 2. Our sequence is 15, 17, 19, 21, 23. This is an arithmetic sequence. So when I write the recursive formula for this, it's just going to be a sub n equals a sub n minus 1 plus the common difference, which is 2. So there's my recursive formula for this sequence. And then if I want to find the 6th term, it's going to look very similar to the last example, where we are going to plug in 6 for n. So a sub 6 equals a sub 6 minus 1 plus 2. Just like last time, a sub 6 minus 1 is the same as a sub 5. And that 5th term up there is 23. So the 6th term is going to be equal to 23 plus 2, which is just going to be 25. So the recursive formula is very helpful if you know the previous term. But if you're looking for a very specific term number, and it's pretty far away from the selection of terms that you've been given. For instance, on this one, if I wanted to know what the 20th term was, the explicit formula is going to be a lot easier to use for that one.